In the previous video, we learned about the different characteristics of a quadratic function. We talked about the axis of symmetry, the vertex, how to tell if it opens up or down, the format, that it is a degree 2 polynomial or a degree 2 function. What we're going to do in this video is we're going to extend that idea. Instead of just looking at a graph and identifying those key characteristics, we're actually going to identify those characteristics from the function itself. So we're going to start by determining how to identify the axis of symmetry, or how to calculate it mathematically from the function. We're going to extend that idea further and determine how to actually calculate the vertex after we find the axis of symmetry. So we're going to walk through that whole process in a similar way that we did the last time, but now looking specifically at the function itself. So just as a reminder, the function, or a quadratic function, is a function of the form ax squared plus bx plus c, where a is not 0, otherwise it wouldn't be a degree 2 function. So what we're going to do when we're finding the axis of symmetry is we're first going to identify a, b, and c, those values specifically from the quadratic function itself. And then we're going to plug those values into this formula to calculate the axis of symmetry, which I'm going to abbreviate as AOS. So we're going to plug those values in. We're going to take the opposite of B, and we're going to divide that by 2 times A. And we're going to put x equals in front because we are talking about the equation of a line x equals some value. So remember, a and b are numbers. This is going to simplify down to be x equals some number. So again, remember the axis of symmetry is a line. It needs to be written as a line. It needs to be written in the form x equals. So let's start with just that. Let's actually calculate the axis of symmetry for numbers 1 and 2 below. And let me adjust this to give a little more space. So we're going to start by identifying the a, b, and c values. So in this case, a is that number in front of x squared, which is -2. B is the number in front of x, which is 16. And c is 9. And you may be thinking, why are we identifying c if we're not using c in this formula? And it's just good practice. When we learn the quadratic formula later in this unit, it's going to be helpful for us to just quickly be able to look at the problem and identify a, b, and c. Now, to find that axis of symmetry, x equals the opposite of b. So in this case, b is 16. The opposite of 16 is -16. Over 2 times a, and a is -2. So this is -16 divided by -4. The axis of symmetry here is the line x equals 4. Similarly here, remember, if there's no number written in front of a variable, that means the coefficient is 1. So our a value is 1, our b value is 1, our c value is 3. So our axis of symmetry, x equals the opposite of b, is -1 over 2 times 1. So this is going to be -1/2. So our axis of symmetry, x equals -1/2. And remember, that is a line. So right now, if I were to graph my quadratic, I could go to x equals 1/2, and I could draw a dotted line that would create symmetry on both sides of my parabola. Now let's extend this idea a little bit further. So how do we find the vertex? So what we learned in the previous video is that the axis of symmetry is the x part of the vertex. So we just calculated the x part of our vertex, both for number 1 and for number 2. So the x value of the vertex on number 1 is 4. The x value of the vertex on number 2 is -1/2. What we need to do is to find the y value. And in order to find our y value, what we need to do is plug this x back into our original function to determine our new y value. So I'm going to put, we're going to find y so that we can finalize our vertex. So -2 times x, and in this case, the x value of our vertex is 4. So -2 times 4 squared plus 16 times 4 plus 9. 4 squared is 16. 16 times -2 is -32. 16 times 4 is 64 plus 9. 64 and -32 is 32 plus 9 is going to give us 41. So the y value of our vertex is 41. So this right here is our vertex. So again, what did we do? We found the axis of symmetry, x equals the opposite of b over 2 times a. Find those values from ax squared plus bx plus c and simplify. Then to find the vertex, we use our axis of symmetry and then we plug that x value in for x into our function to find the y value of our vertex. So let's go ahead and look at number 2, and I know that number 2 is a little bit more scary just simply because there are fractions, but have no fear, we can get through this together. So we're going to find y. So negative 1/2 squared plus negative 1/2 plus 3. Negative 1/2 squared is negative 1/2 times negative 1/2, which is 1/4, minus 1/2 plus 3. So in order to combine these fractions, we need a common denominator. And I am going to show these steps. I don't need to multiply 4 by anything. But if I multiply 2 here by 2 over 2, and why am I multiplying by 2 over 2? Because I want the denominator here to be 4, so that I have a common denominator and I can combine like terms there. If I multiply here, 2 times 1 is 2, and that makes sense. 2 over 4 does simplify to be 1/2. 2 is half of 4. And then similarly, if I do this same thing with 3, if I need 4 in the bottom of my fraction, this is going to become 3 times 4 is 12 over 4 times 1 is 4, and that makes sense. 12 divided by 4 is 3. And now that all 3 of these fractions have the same denominator of 4, I can keep that denominator and combine my numerators. 1 minus 2 is negative 1 plus 12 is 11. So the y value of my vertex is 11 over 4. And that's really all we're doing. We're calculating that axis of symmetry just as we did here. We're plugging that axis of symmetry in to find the y value of our vertex. And we're writing our final answer as an ordered pair. So let's just look through a couple more examples. All right, number 3, I'm going to encourage you to pause the video, identify A, B, and C, and then calculate that axis of symmetry, and then unpause the video to see how you did. Don't go all the way through, just get through the axis of symmetry portion. All right, hopefully you have had time after pausing the video to identify that A is 1, B is negative 4, and C is negative 10. And then to calculate the axis of symmetry, x equals the opposite of b, which is positive 4 over 2 times a. So the axis of symmetry is x equals 2. 4 divided by 2 is 2. If you got that correct, cell 5, give yourself a high five here, and then go ahead and now calculate the vertex, remembering that you already found the x value of the vertex. You just need to find the y value. So go ahead and pause the video. Hopefully you had time to do that. So what I'm doing is I'm plugging 2 in. So f of 2, which you can think about just as y. F of 2 equals 2 squared minus 4 times 2 minus 10. 2 squared is 4. 4 minus 2 is 8 minus 10. 4 minus 8 is negative 4 minus 10. This is going to give us negative 14. So our vertex is positive 2, negative 14. Now I encourage you to pause the video and work through number 4, and be careful. Notice that there are only 2 terms, so one of your variables is going to have to be 0, but be careful. Make sure you choose the correct variable to be 0. Hopefully you paused the video. A is 2, B is 0, and C is negative 4. So we know that B is 0 because there is no bx term. That's why we know that b is equal to 0. So x equals the opposite of 0 is still 0 over 2 times 2. Our axis of symmetry is the line x equals 0. That is also the x value of our vertex. To find our vertex, we're going to plug in x equals 0. So y equals 2 times 0 squared minus 4, which is negative 4. So our vertex is 0, negative 4. Now, just to extend this idea a little further, let's talk about number 4 here. Let's tie back to our last section. Does this parabola open up or down? I want you to ask yourself that question. Does this parabola open up or down? And the answer is that it opens up. And why does it open up? Because A is a positive number, so it opens up. What else do we know about this parabola? We can identify the domain, and we said in the last section that domain of all quadratic functions that open up or down and are continuous is negative infinity to infinity. And you will see cases specifically where we're talking about word problems where this domain is not going to be negative infinity to infinity or all real numbers. But in this case, as a function, that is what it is here. Our range, so our vertex, which would be here, our vertex is a minimum, and the minimum value is the y value of the vertex, which is -4. So the lowest this graph ever goes is -4, which means our range, if it is going the lowest is -4, then I'm going to have square brackets with -4, and it goes up forever to infinity. So remember, just because this is a different section than 9.1, that doesn't mean that all the things that we learned before don't still apply. And really being able to look at a function and identify these characteristics right away, whether it opens up or down, whether it's going to have a maximum or minimum value, what the domain is, all of those concepts are really going to tie together to make a well-rounded understanding of quadratics that's going to help you in the future. So key idea in this lesson today, calculating the axis of symmetry and using that to find the vertex when you are given a quadratic function. If you want more information about how to identify those things from a graph, check out the video for 9.1. I look forward to supporting you on this in class. Thanks for listening.